Hello, everybody, and thanks for joining us today. This is Bruce Milne. I'm the Vice President and Chief Marketing Officer for Pivot3. We are a leader in the hyperconverged infrastructure space, and we're on behalf of Pivot3 and on 451 Research, I'd like to welcome everybody, say thank you for attending the webcast today. Leading off on today's discussion will be Tim Stammers, who's a Senior Analyst at 451 Research. He's going to talk to us a little bit about the state of the market of hyperconvergence, and then following that we'll have George Wagner, who's a Senior Product Marketing Manager here at Pivot3, to talk to us a little bit about the hyperconverged offerings from Pivot3. Before we get started, though, I wanted to talk about a couple of housekeeping items. After the presentation, we're going to have a quick or a brief Q&A session. So if you have questions, type them into the question box on the interface that you see online. To ask a question, just type it in the screen below, and we'll get to as many as we can at the end of the session. And if we don't get to all the questions, then my commitment is we will get answers out to all the attendees, even if we don't get to them during the course of our session here. The presentation and all the slides are going to be made available after the webcast. We'll send them out by email, so you'll be able to download those. And the presentation, we really value your feedback on this presentation, on this webinar, so please do take a moment to provide your feedback throughout and after the webinar. So with that, I'll turn it over to Tim and George. So Tim, take it away.
Always helps to come off mute, doesn't it? Thank you very much for that introduction. My name is Tim Stammers. I'm a Senior Analyst at 451 Research, and we're an IT industry research firm. So welcome in, bienvenue, bienvenida. I'm going to start with an overview of hyperconvergence, market, applications, and technical aspects of hyperconvergence. So during the next 15-20 minutes, I'm going to answer the question, true or false, hyperconvergence is not a new wave. I'm going to explain why it's mostly, but not entirely, mostly about architecture. I'll talk about the architectural pros and cons of hyperconvergence, and finally I'll talk about what you should look for when considering a hyperconverged system, and how to judge between one vendor's product and another's. So there is no doubt about it, it is a new wave. Hyperconvergence is not just the latest IT industry buzzword. The comment at the top of this slide came from a CEO at a very major storage OEM. I can't tell you who it was. It was a comment made during a private discussion between that CEO and 451 Research. And the significant thing is that we were actually talking about software-defined storage and flash. And that particular CEO said, yeah, those are challenges, we'll deal with those. The bigger challenge is hyperconverged storage. And you should bear in mind that flash has been, we're still going through the flash transition. Flash was a major impact on the industry. There were OEMs that handled the transition badly. Some of them admitted quite openly to handling it badly. And this particular CEO said that's nothing. Hyperconvergence is an even bigger wave. Why is it a bigger wave? Biggest, simplest reason is because hyperconverged systems are simpler to install and maintain and operate than conventional storage systems. The other reason they're a major threat to the OEM, and this is quite interesting, is that they are frequently bought, hyperconverged systems are frequently bought by the VM admins or the application managers, not the storage guys. And that scares the OEMs because the OEM sales guys don't have any relationships with the VM admins or the application server guys. And the wave has happened surprisingly quickly. It's, 4 or 5 years ago, hyperconvergence was a very exotic word. Now there are a number of companies seeing very fast sales growth. I'm going to show you some numbers in a minute on that. How big is this wave going to be? At the very least, it will be big enough to take a significant chunk of the market. Nobody knows how far upmarket hyperconvergence can go. It's a discussion point in the industry. How much of conventional fan storage will be replaced by hyperconverged storage? We don't know yet, but like a lot of data center technologies, it's starting at the low end, and it will take time to reach its full impact. it'll take a few years yet to reach its full potential. And I personally think it's going to become, it's a bit of a milestone in data center technology. If you're a nerd following data center technology history, the emergence of hyperconvergence will be similar to the change from mainframe to open server, the change to SAN storage, standalone SAN connected storage, open source Linux. It's on that scale, and I really don't think that's an exaggeration. It's certainly on that scale. Okay, next slide. All right, this is the important slide perhaps. Money talk. This is where people are spending their money. This is 451 Research's prediction about market growth for the total hyperconverged market. And that's 41% CAGR between 2015 and 2020. And yes, it's a prediction, and predictions aren't always correct, but we're certainly not alone. This is not an unusually optimistic view of the hyperconverged market. And that's why we've already seen OEMs taking big moves to protect themselves against hyperconvergence. Obviously, by adopting the technology themselves, we've seen some big acquisitions happening. So could the chart be wrong? Yes, the prediction could be wrong. But if you look at the first two bars, those are important because those two bars for 2002 and 2016, they're hard numbers, they're fact, not forecast. And for 2016, Hyperconverged scored about $2 billion revenue. That is about 8% of the total $25 billion market for SAN-attached storage. That's carved 8% out of that market. 8% is only, obviously, it's a small minority at the moment, but it's significant because it's growing fast. And it's significant because it's coming from, a lot of it's coming from non-OEM suppliers. Most of the market buys from OEM suppliers. When they're buying from smaller emerging suppliers, it's because those emerging suppliers have got something to offer that is distinctly more attractive than the conventional gear being sold by the OEM. And if you go back to the forecast itself, that right-hand bar, that's about, what is it, about $6 billion. That means that we're expecting hyperconverged infrastructure to account for about 25% of the market by 2020. That's a 3-4 years' time. So far, the applications have been initially focused on VDI, remote offices, backup recovery, archiving, but they have been widening. So 451 has a service called Vote. We survey very large numbers of storage experts at enterprises. Around about half say they're now using their hyperconverged systems for mission-critical applications. So it's spreading, not just growing in usage, but it's spreading in applications. The obvious question is why? First of all, it's a simpler architecture. Not all developments in IT, but a lot of them are driven by the need to simplify things, and that's especially true for storage. So I will go on, I'm going to go on to explain this architecture. So it's worth bearing in mind what's happened with convergence, and I want to distinguish convergence from hyperconvergence. Convergence appeared on the market about 8 years ago. EMC was the first with a product called vBlock. I'm sure a lot of the audience are well aware of vBlocks. Other vendors followed, NetApp followed, another famous one. All the OEMs offer convergence. The reason why convergence has become so popular, I think it's heading for about a $2 billion revenue now, and it's still growing fast, is because it makes life much simpler for customers. But it's not a change in architecture, it's only a service. You buy a converged system, you're buying a conventional setup that has been pre-assembled, pre-cabled, pre-integrated and delivered to your doorstep, ready to bolt into the rack. You're also getting single support, single service support. It's a service. I like to think of it as a bit like IKEA delivering furniture to your house pre-assembled. You could also throw in the single source support is really important. So that just the simplicity of having the damn stuff pre-integrated and ready to run has driven convergence sales up. But convergence is not a change in architecture. Hyperconvergence is, and it has a much bigger impact. So the reason that has driven hyperconvergence into the market, you've always got to ask yourself, why didn't this happen 10 years ago? Two things. The rise of virtualization. Virtualization is now extremely common. We're looking at about 80-85% of applications are running on virtualized servers. And Intel has done everybody a favor by being able to stick to Moore's law. So we have a lot of processing power in servers, and a lot of those servers are virtualized. Enter hyperconverged storage. So this is the architecture. Easiest way to explain it is to compare it to conventional architecture. On the left is the conventional system. External shared storage, a storage network connecting the server to the external storage. On the right is the hyperconverged, and you have completely lost the storage network and the external storage. That has obviously simplified deployment considerably. The servers are still there, but now instead of the standalone storage, there's pooled and shared storage provided within the servers themselves, and that storage within the servers gives the same services and features that you get with an external storage box: snapshots, clones, thin provisioning, replication. If you add a server to the cluster, you automatically add storage to the cluster, and that storage is absorbed in the pool. All this is done using software running on the servers, and that's why sometimes hyperconvergence is called virtual SAN or server SAN, or sometimes the abbreviation HCI, hyperconverged infrastructure. Well, the bottom line is that software replaces standalone storage in the SAN. That's the foundation. Convergence was a step towards simplicity. Hyperconvergence is a much larger step. And it's also worth noting here that this is next generation or current storage. I think a marketing person would call it next generation. I would call it current storage. These hyperconverged products are recent designs, so the engineers have built into them the features that they would like to add now, that you customers want. And that includes things like per VM management, making management of storage for virtualized servers much simpler, real-time tiering, so you can get much more out of your flash, real-time rather than just scheduled tiering, proper real-time tiering, deep compression, QoS controls. I'm going to talk a little bit more about QoS controls later. There are hyperconverged products on the market that would be pretty competitive. They would certainly be competitive if they were standalone products, simply because they are, whatever you want to call it, next-gen or current generation products. So now we'll go a little further into the technology itself. When my screen updates. Here we go. And we're going to have a look at the pros and cons. I skipped forward one more, I'm sorry. Broadcast is running a bit slow. Here we go. Architectural pros and cons. So hyperconvergence is great, yes it is, but every architectural or engineering solution has drawbacks as well as advantages. So I've listed them here. Starting with the pros, the first two bullet points are obvious. No SAN, less hardware. That means simpler installation and a smaller footprint, which is why remote offices have become a very popular use for hyperconverged systems. And that is especially true for large organizations. You've got a lot of remote offices. If you can cut some time off installation and maintenance when you've got a lot of remote offices, that really helps. But there are other less obvious advantages. There's a fundamental architectural benefit which can be exploited. It doesn't always work, but it can be exploited, that you're storing the data on the server, and we all know fundamental architectural principle: the closer the data is to the CPU that actually wants to use that data, the better the overall performance. So flash drives inside a hybrid system or an all-flash storage system boost performance, but the SAN is still in the way. The SAN still adds latency and reduces performance. You don't have a SAN with a hyperconverged system. You get more benefit from the use of flash. Another advantage of hyperconvergence is that storage scales with the servers. That's often very good, especially, for example, in VDI. But it's also a downside, and I'll talk about that. And finally, I have synchronized storage, server and storage refreshes. I don't think that really needs explaining. That's a self-explanatory. How about the cons then? The most common objection raised to hyperconvergence is the so-called lockstep scaling of storage and compute resources. If you want to add storage, you have to add a node, and that means adding more compute resource, even if you didn't want that. There are ways that hyperconvergent vendors have addressed this issue. You can add storage to some nodes, but there is a limit to how much you can separate the storage and the compute resource scaling. You may also suffer lock into a hypervisor. Not all the hyperconverged products out there support a range of hypervisors. If they don't support the one you're using, that's clearly off the table, that particular product. And then finally, if a server or a node goes down in a hyperconverged cluster, the rest of the nodes in that cluster can't see the data on that node anymore. That's why in the majority of hyperconverged systems, the data is protected and by distributing full replica copies of the data across the cluster. That works fine, but you have two problems with that. The first is that it results in a very high capacity overhead. Now, RAID 6 has got about a 20% overhead, RAID 6 as using conventional storage systems. In hyperconverged using replicas, one and more often two replicas means you've got 100% or 200% overhead. As we move into a world of all flash storage, that is an expensive problem. One of the solutions for that problem is erasure coding. The industry is moving towards erasure coding, and our host today, Pivot 3, I'm quite sure, will be talking about erasure coding because that's what they're using. There's another issue with losing a node, which is that when you lose a node, the rebuild time with replicas can be extremely high. That cluster will have to rebuild its replicas and redistribute its data, and that can take an hour, 2 hours, during which time the performance is heavily reduced. And that's a big enough problem that by default, the automated kickoff for a rebuild is delayed by 30 minutes to give the administrator time to check, was it just a cable that was yanked out? So I said I'd talk about the criterion for which the hyperconverged product. These are the classic criterion for any storage system. Those are actually pictures of Sumerian beer tablets, Sumerian clay tablets, which might even have been used as beer tablets. They're about 3,000 years old. This was pretty much the first information technology or first major step in information technology writing. And those guys were considering exactly these criterion. This is what you need to consider when you're buying a storage system, these 6 features. So I will click and we'll look at what to look for in relation to those criteria when you're considering a hyperconverged product. And alongside the potential performance benefits, it's probably worth, I'm not going to go into detail about all of these criteria, but it's probably worth looking at the ones where the hyperconvergence architecture actually has its downsides. So, for example, you would want to consider capacity utilization because that's a downside of hyperconvergence. How is the particular hyperconverged vendor distributing data? Are they using full replicas with that expensive overhead, or are they using erasure coding? In some cases, they have managed to implement RAID, but that's not at all usual. You want to look at the cost in terms of utilization rates. You might want to look and see if they offer DD for compression. Check what is the performance impact of that DD for compression, because often it can be very high, and the vendor will actually advise you not to use it for performance-sensitive applications. In terms of performance, another feature to look for would be QoS. QoS is certainly an emerging feature. Every vendor that 451 has spoken to about it has acknowledged that QoS is something they would like to add to their products. It's a blurry, vague term. It's been around for a long time. Be aware that it's actually a developing field, and there are products out on the market that offer QoS, which is far more sophisticated and hence far more useful than other vendors' QoS offerings. QoS, at the bottom line for QoS means a system that will intelligently manage the situation when there aren't enough resources to go around, when there's contention. So you're looking for something that doesn't just put a minimum throughput on an application and say, you can't have more than that. You want a system that's got algorithms built into it that will deal with the situation intelligently and understand the score when there aren't enough resources to go around. Ideally policy-based, so you don't have to know about your IOPS and throughput, you just choose gold, silver, bronze levels, and it runs itself. I think I'll leave it at that. I will be here for questions. Thank you very much.
Excellent. All right, well, thank you.
So let me introduce George Wagner, who's going to describe Pivot 3's capability in some detail. So George?
Hey, thanks, Bruce, and thanks, Tim. So my name is George Wagner. I'm a Senior Product Marketing Manager here at Pivot 3. And today, my portion of this presentation, I really want to discuss how hyperconverged infrastructure is evolving to do more, or probably more specifically, what's needed for it to do more. What are those key features and functionality, and kind of what we're doing here at Pivot 3 to enable that. And before I go on, I have to say, Tim, I really like the "look no sans" quote you had. I'm going to have my lawyers look at that and see if I can trademark it. Very good.
I'll take a royalty.
Those of you who were unfamiliar with Pivot 3, I know Bruce mentioned it briefly, but we are considered the architectural leader in hyperconverged infrastructure. We have over 2,400 customers in 54 countries. And what we're known for up until recently, and including now, is highly efficient, highly available hyperconverged infrastructure that delivers on performance and is simple to manage. And what I'm going to discuss with you today is some new and exciting innovations that we've made and announced over the last day or so that will really enable this next generation of hyperconverged infrastructure. One of the things that Tim mentioned was that many customers, I believe it was about half of some customers that they interviewed, said that they were using hyperconverged infrastructure for their mission-critical applications, which is fantastic. What we want to see is customers using it not only for the mission-critical, but also putting their business-critical and non-critical apps on there simultaneously, and that's where features and functionality such as quality of service really come into play. So with that, let's dive right into it. So for those of you who don't know me, which is probably most of you, I wasn't always in marketing. I was an IT manager for many years before taking out the propeller hat and moving into this side of the business. But I say that because I really understand the complex issues that you're dealing with, albeit I'm about 10 years removed, so it's much more complex these days, and that's compounded by data rates exploding, and end user expectations never being satisfied, always going up, and on top of that you're being mandated by your organization very often to kind of drive operational efficiencies, drive down costs, and with all the data growth, trying to keep track of your footprint, et cetera, et cetera. So, there are definitely, it's leading many to explore other options besides your traditional three-tier IT infrastructure. And so, as Tim was mentioning, many customers today are considering either traditional IT, sticking with that, or taking the leap and looking at hyperconverged infrastructure. Now, with traditional IT, there's a benefit that it's proven, right? Not every combination of server, networking, and storage is going to meet every challenge, but you can usually cobble something together that works. However, it could be slow to deploy, expensive to administer because you need specialized skill sets that do cost money, right? But for many, they just feel comfortable that, hey, you know what, this has worked for me in the past and it'll continue to work for me, so I'm just going to leave it alone. Whereas hyperconverged infrastructures introduced a new dynamic, and that is around increased agility. So very quick to deploy, simple to manage. Operational efficiencies have definitely been driven up in many respects, and it's been I'd say the only caveat. I wouldn't say it's a caveat because it was designed for this, but for hyperconverged, a lot of it was predicated on the notion of delivering for a targeted application, right? So a VDI, for example, or as Tim was mentioning, some mission-critical workloads, but for the most part, it was not designed for multiple mixed workload consolidation. Right? So, in my professional capacity in marketing, and I've worked in product management, as well as I get a lot of face time with customers. I get to ask them questions to kind of discover new opportunities and ways we can help them. And one of the things I've asked them in the past was, would they like to kind of reap these benefits, the benefits they've seen in Hyperconverged, across more of their data center? And these are customers that we currently have today using HCI. And the answer is absolutely yes. But the question in the back of the mind is, will it deliver? And so if we're going to answer that question, we need to take a look at kind of what it's going to require, right? What's going to require to take it to the next level. Next generation hyperconvergence, for lack of a better term, and it's, as you can see, we got the criteria for success, and these are some things we need to consider when we're looking at moving from a targeted application type scenario to more of a multiple mixed workload. And before they do that, HCI vendors need to solve a few challenges that are common across Hyperconverged, and even a lot of shared storage vendors. I mean, I'm a storage guy, that's my background, and I'm very familiar with these challenges because they look very familiar from storage as well. And I have to tell you that many storage vendors haven't even nailed all of these yet, okay? And they've been doing it much longer than Hyperconverged. So it takes a lot of engineering, a lot of design efforts that have to go into it to make it work. And I think if you look at the second three, simple management, efficient resource utilization, simple scalability, those are pretty clear-cut, and those are what you'd expect from most hyperconverged vendors, and I'd have to say probably most of them deliver on that. Extensive data services at the very bottom. Hyperconverged is a fairly, relatively new architecture, right, in the last 10 or so years. So they're working feverishly to get those in place. However, consistent performance is the one enabler that is required to really get it over the hump and make it suitable for being deployed for mixed application workloads. Okay, so that's kind of where, and in fact, I would say that consistent performance is what's keeping many from going that way, and in fact, even in shared storage, it keeps many customers from moving from DAS to SAN, right, to conventional shared storage, because they don't want to have to deal with the resource contention issues that arise across SANs. If you think about those of you who have shared storage environments, when you have multiple workloads contending for resources simultaneously, how do you pick the winners and losers? If you're unable to pick those and intelligently manage that performance, then you're not going to take the risk of putting those mission-critical workloads into that pool. You'll just take and silo it somewhere else. So these are some of the principles that we adhere to when designing our latest hyperconverged software platform, ACUITY, and that's kind of what we're going to go through today. Now, as I talk through some of these key features and functionality and explain why it matters, why it's important for you, keep in mind that none of the features that you see, none of the functionality that you see in this slide is new. Okay, we have multi-generational quality of service, so we really believe the fact that if you create the right intelligent software, right, the right software platform, that you're able to manage all the resources intelligently, and really, customers can instruct the system on how it should behave, and it follows those instructions. That's really where you need to start. After that, you ensure that you have the correct underlying architecture, underlying hardware, and then of course at the end you've got your data services to fill in the gaps where, of course, you're accustomed to data services on your shared storage, and you don't want to leave those behind. So when we look at each one of these, first off is the priority-based and policy-based and priority awareness. So we do have an advanced quality of service engine that I'll explain a little more about in a moment, and it's one of those that Tim is talking about. There's not all QoS is the same, and some is more advanced than others. I'd say this is very advanced, and in fact, it's probably more advanced than most storage vendors have today. And it actually extends down to data protection as well for snapshots, and they are you can schedule them, etc. And I'll explain the details of that in a moment. From an architectural perspective, we've done some interesting things and really departed from the traditional single-tier architecture where you may have either all flash or hybrid included and then have some cache tier in there, which is your traditional single-tier architecture, and moved to more of a multi-tier architecture that has multiple media types in there, such as RAM and NVMe, PCIe flash, SSD, and hard drives, and then of course it's the software that intelligently moves data between those tiers real time. And I don't want to forget, because it's extremely important, the data service in our patented erasure coding. So once again, something that Tim did mention is data protection is extremely important, especially when you have all your eggs in one basket. And it can sometimes be costly when you consider replication between nodes. So that's why features such as erasure coding are definitely important as far as being able to keep it efficient. And we definitely have that in there. I'll talk more about that here in just a moment. But first and foremost, I know, and I'm a victim of this at times as well. But if you are multitasking, I urge you to stop for a moment and listen in, because this is really the most important, in my opinion, most important piece of this entire presentation, for me at least, and this is really what enables us to take our already advanced architecture and make it consumable for multiple mixed workloads, and that is our priority-aware performance. So, as I mentioned, the only way the customers are going to consider hyperconverged is if they know that they're not going to run into resource contention, and that's where our advanced quality of service comes into play. It's built around 4 pillars. One is our priority-based application of it, our prioritization, our data placement, and our data protection. Okay, and as you can see here in this slide, I've got 3 workloads. Each of these have varying degrees of importance to the organization. I would have to say probably the order database is quite more important than the dev database, right? And so what we've done is we provide, Pivot3 provides pre-configured policies that allow you to align your performance, the system performance, to your business priorities. And each policy, we have 5 policies into the system. Each policy defines performance, minimum performance levels in terms of IOPS, throughput, and maximum latency. And those can be changed on the fly. You can schedule those as well. So if you have more of a cyclical application workload that you have reporting that happens at a certain time of the month or the quarter, you can select it. You can change it to where you can move it from, say, a policy 4, which is a less critical policy, up to a policy 1 for a temporary period, and then move it back. So that's important, right? And why that's different than others that are out there. Well, we set performance minimums versus performance maximums, so your workloads have access to all the performance all the time, unless it needs to hit its minimum performance level. And at that point, we can throttle down other applications. And that's where it gets to kind of that prioritization of resource allocation on the other side of the screen. Associated with every policy is what we refer to as a service level. And the service level determines the resource priority that will be given to the workloads, the applications, the VMs that are associated with the policy. So in the case of an order database, it always has performance resources. In fact, they're guaranteed to every volume that's that's associated with that particular policy. And the idea here is if you, as the virtualization admin or the IT director or manager, are confident that your applications will meet their SLAs, then you'll be confident deploying a Pivot3 system into your data center and allowing it to really deliver those operational efficiencies and deliver and consolidate multiple mixed application workloads. So how simple is it? It's very, very simple. In fact, as I mentioned, we do have these policies. They're pre-configured in the system. Customers often ask, well, if they're pre-configured, can I configure my own? The simple answer is, well, we could allow you to, but this quality of service feature has been in our products, in one of our products for the last 5 or 6 years, and no customer, a lot of customers have asked that question, but none have ever taken us up on the offer. Okay, so upon, when it's time to create a volume, or maybe perhaps a volume is also a data store, what you're going to do when you provision that volume is select a performance policy, right, that defines whether it's policy 1 through 5, and then also that in turn also defines its service level, whether it's mission critical, business critical, and non-critical. And from there, if I decide to, I can also create a data protection policy. And a data protection policy, in essence, prioritizes snapshots, for example. So if I have snapshots that are occurring across the system, certain applications take priority, and we can enforce those. Now, snapshot QoS, the data protection QoS, is modifiable by you. You can create your own policies. But that's just step 1. Step 2, if you decide to create a schedule, you can go ahead and do that. And then you're done. You want to go back and change it, you can change it on the fly, but it's that simple. We don't require, it kind of takes the guesswork out of knowing exactly how much performance is required, because when I talk to customers, many of them know that certain applications are important, but they don't know the exact performance requirements. Well, they do perhaps for a database, but not the exact requirements. This allows them to do it very quickly. Now, from an architectural standpoint, and this is a feature that we've touted for quite some time, we take a different approach than many of the HCI vendors out there, in that we do a distributed scale-out architecture, so that rather than taking and tying each VM to the local resources that more than likely can't be scaled, we can take and aggregate every single HCI node into single resource pools that then allow us to aggregate the performance resources, disk, network connections, etc., to deliver more performance. And that performance is scales, of course. So in the case of, let's say, a conventional HCI architecture that has 12 drives, and the VMs have access to those 12 drives, whether it's a hybrid or flash, on the Pivot 3 side, we can take those 3 nodes and make it 36 drives. And so now I have my VMs going across 36 drives, and if I intend to scale it, I can scale it up to 144 drives, and that of course increases performance considerably. And one of the caveats, or I say one of the cons for HCI that Tim had brought up during his presentation, was that for many solutions you have to scale in lockstep. In our current shipping product, that is definitely not the case. You can scale compute and capacity, or you can scale capacity only, or you can scale compute only. So it's very flexible in that regard. But I would say, one of the more important things, and we've actually improved upon this with the release of our ACUITY software platform, is our ability to deliver not only efficient, high availability, but also high availability performs, right? Because what's better than high availability is being able to meet your SLAs when you have a drive go offline or a system go offline, right? So Tim had mentioned erasure coding being a technology, a data protection fault tolerance technology that's gaining prominence in the industry. This is something that we've specialized in and have patents around, and have been doing it for years. We have ours, in fact, allows our customers to protect data, protect their volumes, protect the nodes from multiple drive failures, single node failures, and what has always been the case is that because we have, in many cases, if customers go to scale at 144 drives in a single cluster, they can take advantage of all the spindles, but I lose a single drive, that performance impact is under 1% total versus maybe 6% of a 12 drive solution. So impact is much lower, but now with the quality of service and of course the service levels, we can now guarantee performance to our mission critical workloads. So any workload that's associated with that policy 1 mission critical if I lose a drive or lose a node, we still guarantee that the minimum performance resources will be delivered to volumes in those policies. So that's huge. Once again, in giving customers peace of mind to know that they can run these. In fact, I would say a lot of storage companies can't even do this today. Our solution that has this with Pivot 3 was one of the more advanced or most advanced in the way we do quality of service, and all we've done is simply added that into our HCI system. So we get the great efficiencies in here as well, up to 94% storage utilization. So it starts off at better utilization than traditional one- and two-way replication, and it scales from there. 94% at erasure coding level 1, 82% at erasure code level 3. So it's definitely a benefit from not only an availability standpoint, but a performance standpoint and an efficiency one as well. Now that I've really talked a lot about the intelligence, the software around what we're doing, let's take a look at how we designed the underlying architecture to be different, designed it for performance. As I mentioned, many of the systems that are out there today are running single-tier architectures, whether it's SSD, hybrid, et cetera, that are running legacy SATA-SAS, which means basically they're taking SSD, plugging it into legacy controllers, and that's kind of, although there's some excellent performance outcomes from that versus disk drives, it's still not as optimal as it can be. And in fact, part of our multi-tier architecture does employ that. However, in our multi-tier architecture, we also use memory as cache. We use NVMe PCIe flash, and I'll explain why that's important in a moment, as well as a high-capacity tier, which consists of either flash or hybrid, which is a combination of SSD and traditional hard drive. But why NVMe is important is that it really is the first implementation of NVDIMM or of flash, like SSDs, for example, that treats flash appropriately, treats it like memory rather than treats it like disk. Right? Instead of using a SCSI protocol, we have NVMe has its own command set that's optimized for flash. It's directly it's closer to the CPU, which if you're talking about data storage, the fewer hops the better. In this case, this is right next to the CPU, so it's much faster, lower latencies, higher performance. It allows us to do about 2 to 3 times more VMs per node than most others. And if you think about just straight performance, for those of you who are kind of gearheads out there, I would say, very conservatively speaking, that NVMe PCIe flash can deliver 450 times the IOPS that a SAS SSD can, or then a SATA SSD, and about 119 over what a SAS can. And I was told yesterday that those numbers are actually better. So I'll probably update those as well soon enough. But what we're doing is data lands on a tier that's appropriate based on the policy setting. In the case of an NVM, or in case of a non-critical policy, data comes in. Every single write that comes in to the system, regardless of its priority, is handled by the NVMe flash tier. And then for non-critical volumes, they're destaged to that high-capacity tier where they stay. They don't heat up when they're read and move back up into the cache portion of it, because there are 2 portions of the NVMe card, both a cache and a persistent piece. And then if it's a mission critical or business critical, it'll be written down to the NVMe, and it'll stay there until it ages out, and it'll move down to the high capacity tier. And based on the policy, if it's a mission critical, 1 hit will move it up. If it's business critical, maybe 8 hits will move it up. But it's all prioritized. Once again, it's being able to use this intelligently that allows us to not have to populate an entire box with NVMe flash or the most expensive tier, instead of having to size it for the most. Our worst case scenario, we size it appropriately based on kind of what our software is capable of handling. From a platform perspective, kind of going all the way down and looking at the vehicles that we use to deliver this kind of next generation hyperconverged architecture, we've introduced the new X5 series platforms that are both hybrid and all flash. And as you can see them below, I talked about these clusters and being able to stretch volumes across a single volume across 144 drives, but in fact, from an overall system standpoint, we actually have the largest recorded HCI installation out there, and it's all managed through a single pane of glass. So you can have multiple clusters, as many as you need. We haven't hit a hard limit yet. I don't like using the term unlimited ever in IT, but I will say that we've not hit a hard limit on any of that. We have customers that are managing into the many petabytes actually of capacity. You'll see that there are NVMe in there as well in these systems. We do have the option of adding GPUs or PC over IP offload cards or the Teradici cards. From a networking perspective, we support both 10G base T and SFP plus 10 gig. A little faster on our nodes that contain NVMe. So those are the systems that we use, really the modular building blocks that our customers are using to build these systems today. So with that, I want to leave some time open for Q&A, and I'll pass the mic back over to Bruce.
Hey, George, thanks very much, and thanks for that overview. So before we get into the Q&A, there are a couple of questions from the audience. But before we get into that, I wanted to point out that there are some attachments documenting some of the capabilities that George just walked through. If you look in the user interfaces and attachment and links section, and there are 4 specific documents in there that you can download at your leisure. We'll also provide links for those in the email that follows up after this webcast. So a couple of questions. One right out of the gate for Tim. Tim, I thought perhaps you could recap for us what's driving the expansion of hyperconvergence in the data center. I know you covered that briefly in your comments earlier, but we've heard growth estimates that range from 100% year over year to 350% year over year. That's pretty incredible growth for a category, or as a component of the infrastructure space, but as a category, that's a pretty incredible growth rate. Any thoughts on what's driving that extraordinary growth?
Yeah, the change in architecture, hyperconvergence, it just comes back to those basics. No SANs, meaning smaller footprint, smaller physical footprint, easier to install, simpler management, per VM management, newer features like real-time tiering, erasure coding. And again, it's the top line message is about simplification. It's about the fact that storage has always been complex to run, and anything that helps simplify it is going to attract buyers and users. And the word is getting out there. Hyperconvergence, as I said, there are detractors. It's an open debate in the industry. How far is hyperconvergence going to go? And there are people who argue that it has the potential to entirely replace conventional SAN infrastructure, and other people that say no, it won't go that far. But even those second group of people have to acknowledge that it's going to take a large chunk of the market. Yeah.
And do you think the economics have some part to play in that as well? I mean, you're looking at significantly lower costs to deploy the same amount of storage, and what we're seeing now with ACUITY and some of those other innovations in market, that it's competing with storage area networks on the performance front.
Yeah, absolutely. If you can deliver if you can do the same job for less money, you're going to attract buyers, and that's what hyperconvergence does for many applications, and an increasing number of applications. Delivers more.
So this is a question for both of you. George, Tim mentioned that one of the limitations of hyperconvergence, one of the knocks against it, has been that the growth scaling has to be lockstep growth of storage and CPU at the same time. Is this true in all cases?
Yeah, so it doesn't have to be. It depends on how the system's architected. I like to say that we built our hyperconverged infrastructure with a lot of brains on the storage side, and that allows us to really separate those two if need be very modular. So if a customer, very flexible as well. So if a customer starts with a 3-node cluster of compute and storage, and all of a sudden believes that they need more IOPS only, not just capacity but IOPS as well, they can add a system that's optimized for capacity. You don't have to pay. It doesn't have the CPU, memory, etc. So it doesn't have to be. It's not a tried and true. But in the case of us, especially, I think we can make that.
Okay. Here's a fairly technical question for you, George. What type of snapshots do you use? Copy on, write snapshots, read direct on, write, or other? Is there a limit on the number of snapshots, and do you license the number of snapshots?
Yeah, so I'll start with the license fees first, because I didn't mention that before. There is no licensing for any of our features and any of our products, and so it's all inclusive all the time. So that's nice. As far as the type of snapshots, we are redirect on write, and we like to refer to it as redirect. So it's basically deferred redirect on write. I can't even come up with a good acronym for that. So, but by saying that it's deferred, because of the ingest, because the write request comes in and hits NVMe flash, we can delay that D stage down the disk to an appropriate time to where it makes sense, so it's not an impact. I never say it never impacts, but it lessens the impact, and of course, quality of service takes care of the rest as well. But that's what we do. It's a tiny impact.
Okay. Tim mentioned earlier that QoS and erasure coding are capabilities that have been in market for a while. You postulated, George, that the Pivot 3's QoS is a little different. Any thoughts on how that's different? What would distinguish Pivot 3's QoS from the offerings of anybody else in market?
Yeah, that's a great question. So I've seen, at least, and I'm obviously more sensitive to it than customers are, but a lot of HCI vendors and even all flash vendors claim quality of service in the past couple of years, and some can't even claim it, but most that do are usually referring to either the ability to throttle system operations to take care of overall workload, like the customer's applications, but that's not real. That's more of a throttling mechanism. There's also others that have that do just set quotas, like performance quotas, to say, okay, you're limited here, you're limited here, you're limited there, and it's on one or two of the performance characteristics, like maybe it's IOPS or throughput or latency. What we believe, kind of our philosophy all along, in fact, since about 2011, has been that that's only part of the story. So yes, we do provide a different way to address quality of service by setting performance minimums, and not only that, but including minimum IOPS, minimum throughput, and maximum latency, because latency is the most important piece. I think everyone would believe or would agree with as far as that first policy. However, the next, and I would argue, most important piece is being able to prioritize. And I'm not aware of anyone out there who's able to do that right now. And why it's important is that's not every workload it has the same performance requirements, right, and provides the same value to the business. So if you know that your order database is going to have priority over, say, some task workers, or an operations database that needs to be online but doesn't need all the performance, that I believe will give customers the confidence to deploy this in more mixed workload environments.
Okay. I had a question here, and this might be for Tim, just to get a sense of what you've seen elsewhere in market, and George, from a technical standpoint. Any thoughts on whether InfiniBand as a storage interconnect would further reduce latency?
Oh, wow. Yes, of course it would. Yes, of course it would improve the performance of a hyperconverged cluster. But I suspect that InfiniBand is going to move more over to the HPC side of the market because NVMe is going to be the thing for the future, which is NVMe, the interface that George has already talked about, used with PCIe flash. NVMe is going to be stretched over Ethernet, and it will in future be very low-cost standard Ethernet, a bit like Rocky and iWarp, but it's going to become ubiquitous. So yeah, InfiniBand would accelerate, but within the next few years, 3 or 4 years, people are going to be using NVMe over Fabric. That's my answer.
I'd have to agree with that, and also because in the HCI world, we're cost sensitive, especially as we scale systems. You need to take into consideration, what that would cost to scale, and with 25, 40, and 100 gig connectivity for iSCSI coming down the pipe, in many cases already available. That should help move any performance concerns away from the network. Of course, they always creep back, but I definitely agree with Tim.
Ethernet the prediction has always been Ethernet will win, and it's looking like it's going to win.
Interesting. Tim, you mentioned that erasure coding is coming up more and more, and that we'd be talking about it because Pivot 3 obviously applies that technique. And George, we put a lot of stock in erasure coding because of the enormous data sets that we handle in some of the use cases that we support. What is better about erasure coding when you contrast it with other fault tolerance methodologies?
Well, I'll answer that with the simplest because I don't know much about it. Sorry, George, do you want to go ahead, or?
You're probably more interesting.
Okay, I doubt it. Erasure coding, much lower overheads. Faster rebuilds, I believe. In the era of disk, erasure coding started to be discussed as an alternative to RAID before Flash really hit the market. And that was because, oh my God, RAID 6 rebuilds are they're starting to take an hour. Yeah, RAID 5 rebuild took a long time, and while you're doing a RAID 5 rebuild, your system is vulnerable to a second failure. Along comes RAID 6 as the cavalry, the rescue the situation. RAID 6 is tolerant to 2 faults. But you're still vulnerable to that second fault while you're doing a RAID 6 rebuild, and as disks got larger, that rebuild time started to stretch out to hours, and then people are sweating, please don't let me see a second drive fail before the rebuild's finished. Flash comes along, all the vendors adopted RAID 6 because they said that's what the customers expected. Flash was so fast that the rebuilds initially were very quick, but even with Flash, RAID 6 rebuilds are now starting to stretch out again. Hence, erasure coding is now looking even more likely as a future technology, and it's a current technology because it's in Pivot 3. It is in, other HCI vendors are beginning to offer it, but they're not offering it they're offering it as an option, and there are performance riders when you use their erasure coding. And I'll hand over to George to talk about how.
So I have one more question I want us to get to before we run out of time here, and this is a really interesting and maybe existential question. The death of SAN continues to be postulated much like the death of tape, but there's still a huge install base of SAN and fiber channel systems in mission-critical environments. So first of all, how do you integrate into these environments, or sell the leaders in those environments like CIOs and IT managers and so forth on the idea that these newer systems are going to be just as reliable and just as performant, and convince them to actually abandon storage area networks and other arrays? So, George, any thoughts on that you want to,
Sure.
And then we'll wrap up with Tim's comments on that one.
Well, I'll never make the prediction that there will be the death of the SAN, because people have been predicting tape's death for the last 25 years, and it's still around, and it's actually getting more popular than ever. However, to your question of kind of SAN and fiber channel systems that are in mission-critical environments, I think there's a place for shared storage, and in fact, we offer that today. We have a solution that behaves very much like the Hyperconverged offering, but in a traditional SAN storage, iSCSI SAN delivery mechanism. When talking to customers, or talking to IT managers and CIOs, trying to convince them, I think they need to be convinced that they are going to get the same predictable performance and feature sets from this HCI solution that they have in their current or what they're planning on to replace their shared storage with. I like to think of it as you're basically taking an enterprise SAN and stuffing it into a server, right? So they expect what they expect, that they will, and they want nothing less. And if you ask them to take less, then they're not even going to consider HCI. It needs to be able to deliver what their existing SAN can.
Tim, do you have any further comments on that?
Yeah, I mean, as I said when I was talking in my presentation, this is a big debate in the industry, and nobody has I don't think there's a real consensus yet, other than, as George said, stuff never dies. There's no real consensus yet. How far can hyperconverged infrastructure go up market? It has started at the low end, and it is definitely moving up market, but how far will it go? That's one of the two questions, I believe, and we don't know. So it's yet to be seen. It really is yet to be seen. How do you convince CIOs and buyers that this is hyperconvergence worth considering? You talk to the storage admins, you talk to your technical guys and your operations guys, and actually you also talk to your server and VM admins, because one of the big qualities of hyperconverged infrastructure, which is actually not that much related to the architecture, is the fact that it is very friendly self-service storage for non-storage people. I think that's probably the most important things I can say.
That's terrific. So first of all, I want to say thanks to both Tim Stammers of 451 and George Wagner from product marketing at Pivot 3 for your comments today. Again, I'll remind everybody, first of all, provide your feedback on the webcast right there in the user interface. We appreciate that feedback. It helps us get better and serve your needs better. I would also remind you that we do have a number of attachments that you can download directly from the interface. We'll also provide a link to all those assets when we follow up with an email, and we will follow up with a transcript of these questions and answers. Any of the ones that we didn't get to, we'll address in that email as well. And we invite you to visit us at pivot3.com. We made a major announcement of a new product release yesterday of ACUITY, as George mentioned, and there's an awful lot of information out there on ACUITY and the advantages it brings to your data center, especially as you start to expand the footprint of hyperconverged in the data center, start looking to multiple mixed workloads, how to host and prioritize those applications effectively to make sure that you're getting the type of performance you expect from your enterprise applications. I'm Bruce Milne. I'm the Vice President and Chief Marketing Officer of Pivot 3. I want to thank you for joining us today. Hope this was a good use of your time. That's our goal, is to make this informative and helpful. And we look forward to talking with you soon. Thank you.